Alright, hello. I'm going to open this video by testing my game prototype. It doesn't have a title, it doesn't have sound effects, but it has a lot of visuals. Here, I have a player, grabs his ball, kind of looks like a soccer game, but a soccer game in 2D doesn't really make sense, or 2.5D. Oh no, what is this? This robot, does it want to... No, I think it's gonna hurt me. Oh no, laser. Ah! Okay, get up. Come on. All right, oh, he's gonna shoot me again, huh? It's not leaving you a lot of time to recover here. However, I know something about this drone because maybe, just maybe I built it. It does this other ram attack behavior. Nice, I dodged it. And now it gives me a little window of opportunity to shoot the ball at it. And as you can see, I am stealing energy from the shield. As it does that, now it's gonna try to shoot me. If I can just hit it for... nice. Bang. That went way better than I anticipated. I've practiced opening this video a bunch of times, and you wouldn't believe the weird stuff that happened while I was playing my game. I ran into a bug last session, a bug that never happened in the hours of playtest that I have done. So yeah, let me hop over to the camera. Hello people, my name is Michel, and I make video games in my spare time. I'm a software engineer. I am pretty comfortable with GDScript at this point, but I do not have any professional experience making video games, so I'm learning like the rest of you probably watching this. Spent the last year building this. I'm definitely not one of those guys who follow the standard advice to make small games or just like quickly go build your game loop with ugly assets and standard character capsules and just see if it's fun. No. I am here to learn. So I need to learn how to make assets too. So I'm spending a lot of time figuring out how to make assets and bring them into the game. And I find that this is a good way to learn because the way that you construct your assets influences a lot the way that you decide to implement your code. I don't feel like this is something that you hear a lot. Like, even though like in principle, you should be able to properly detach your assets from the implementation so that you have an easy time swapping and experimenting with assets. When you start animating things, when you start having more complex behavior with like individual parts of your assets that need to be independently animated, things get really complicated and hard to, effectively implement a separation of concerns. So this kind of complexity is what I want to talk about in those videos. I feel like a lot of YouTube videos will cover individual building blocks of making a game. Like they will walk you through, for example, basic state machines for a character controller, or here's a shader for a nice lightning effect. But once you start trying to piece things together, those building blocks are not necessarily meant to fit together really well, and you have to figure out how to do that. You have to figure out how to do that in a way that is sustainable, especially if you aim for something relatively complex, because there's no choice here. You kind of have to build this complexity block by block. And if every time you add a new block, you end up breaking what you've built, it becomes a very tedious and discouraging process. So I spend a lot of time trying to figure out a way to build my game in a way that I can do that, because even though what you see in the game, the drone has a bunch of interesting behaviors already, right? It has like a patrol loop. It defends itself when you throw the ball at it. It closes into a ball and props up its shields, right? It has this laser attack, and then it has this ram attack that it does. All of these behaviors, it's not the end. I want to add even more. I want the fight to feel really lively. I want the drone to feel like a real smart opponent. But I've gone through, just in the process of building these actions, I've broken my game several times and had to refactor a number of different times. But I think I've arrived at a model now that is a lot more sustainable. And I kind of want to share how I've done it. But it starts it starts from the visuals, and it's a long journey. You have to marry visuals and behaviors at the end of the day, and how to do this is not trivial, and it will vary heavily from use case to use case. But yeah, so if you're a beginner to Godot, this video is not targeted at you, unfortunately. That does not mean that you're not welcome, because as a beginner, I think it's good to get a sense of what's involved in making a video game, so that you can scope your own projects better, right? So if you know, for example, that building a ragdoll is this involved, are you still going to want to do it? The answer might be yes, because you're a stubborn person like me. The answer might be no, because you actually want to ship stuff. It's completely up to you. But as a beginner, like I said, I encourage you to stick around, even though I'm going to talk about some concepts that may fly over your head. If you haven't been exposed to some of these things, I'm not going to necessarily take the time to explain every concept that I'm talking about here. There's a ton of good YouTube videos out there to explain concepts that you may not understand in this video. So please do, like UV unwrapping, for example, just one topic, just throwing one out there. If you're a more advanced Godot developer that is familiar with the techniques that I'm playing with, you're welcome to stay. This may give you some ideas for how to implement things in your own game. And if you're an even more advanced developer, feel free to look at what I've done and tell me how I'm doing everything wrong. I welcome the criticism, just don't be mean about it. But yeah, welcome to everyone who wants to stay and watch me ramble about all this stuff for about an hour. In this particular video, I'm going to limit the scope to two kinds of animations and visuals that I do for the drone. I'm not going to go into behavior yet. I'm going to talk about setting up an asset in Blender so that you can animate it properly to make it ready to use and to use it in an animation tree. And I'm going to talk as well on how to couple this with VFX that come from manipulating shaders on meshes that are also attached to your drone that may have behaviors that's independent from the animations that are on the main mesh. So that's the scope that I'm going to cover, and let's get right into it. So I'm hopping over to Blender here. This is my drone blend file. As you can see, there's a lot of meshes that are visible. There's these gray meshes that are without materials assigned to them. These meshes, like I said, the materials are assigned in Godot, but that's not what I want to open this section of the video with, but it just sticks out, so I have to mention it. But for now, I did prepare a little modifier to just put them away so we can focus on the actual model that you see on the screen. This is my drone. I modeled it myself and I rigged it myself as well. I've been spending a lot of time learning Blender in addition to learning Godot in the past year. The very first thing I want to mention about this model is that it is rigged in a pretty advanced way. I followed P2 Design's Art of Effective Rigging 2 to learn how to do this. I am not done with the whole rigging class yet. I've done about, I think, 40% of it. It's split into a number of different projects. And the second project, which I think Pierrick, the author of P2 Design, calls it, it's the spider ball. And the spider ball walks you through everything that you need to build the rig that I've done. In fact, after finishing the spider ball class, I immediately went and made this model and rigged it. So this is a direct application of Pierrick Picot's Art of Effective Rigging class, especially the spider ball part. So I want to show you the rig, because the rig is really what enables me to do animations very quickly and make them look really nice. So I have this armature object. The mesh is parented to the armature. if I go into pose mode, these weird geometrical shape that you see here are my control bones for the rig. I can select all of them and reset the rotations in their position. So this gives me back the rest pose for the drone. By the way, I don't want this to be a rigging class. Don't expect to learn rigging from me. I refer to P2 Design for that. But I will show you what a good and effective rig should look like. So in this ball, this drone, I can grab one of the panel bones right here, and I can open up the drone like this. So the one thing you immediately see is that I have this inverse kinematic chain that is set up with the back of the drone. Right, so all of these here moves in concert. That's because of an inverse kinematic constraint. One thing that you don't see currently that I should expose quickly is that the rig is made out of 3 layers of bone. The very first layer, the bottom layer, I have this bone group here called def.lr. So I know 2 of those bones are gigantic. I'm not going to go into why right now. Maybe I will in a future video. But you can see, I can just hide them so that we see a little bit better. All right. You can see that there's a chain of bone here, and each of those deformation bone is attached to one pieces of the mesh, right? So as I grab this bone, the inverse kinematic chain sort of propagates the motion all the way to the end of the chain at the very back of the drone. So this is very useful. This is very pretty. One thing I want to say about these deformation bones is that those are the bones, like I said, they're attached to the mesh. They're directly attached to the mesh, and those bones are the ones that you will have access to once you've exported your model to Godot. Those control bones that I'm manipulating here, they are not available in Godot, but don't worry too much about it. I will show you that you can still use them in Blender and make your animations with them. And then when you export to Godot, the animation gets baked into the deformation bones. So you don't have to worry about this. Like all of the deformation bones right now, the green color indicates that they are copying the transforms of other bones, or they are constrained, right? So like I cannot grab this bone and move it by itself. Something else is moving that bone right now, like this control bone. There's also mechanism bones, which is like an intermediate layer between the control bones and the deformation bones. But I won't go into those right now. What you really need to know is the very top layer, the one that allows you to control the rig, and the bottom layer, the deformation bones that are exported to Godot. So another thing that is worth mentioning is that, okay, there's the inverse kinematic constraint, but I also have positions and rotation constraints on this. Like for example, I cannot take this thing and move it up and down. It can only move alongside the XY plane. And that's because that's just the way I want the drone to behave. I don't want these flaps to be possible to move up and down. It makes no sense for the drone to be able to do that. And also I have a position constraint that allows me to just like snap the ball back close, right? So like this bone cannot go further than a certain X position and Y position that corresponds to the corner here, right? So these constraints allow me to just manipulate this thing and not worry about moving it in a way that is unnatural. So another example of like constraints being implemented, right? All of these bones are structured in a parenting, right? So like these bones that I have over here are parented to the bone that controls this outer panel. So I can open this like this, and then I can still manipulate this bone and then it will follow, right? So this is just parenting. But you can see that like I limit the rotation of this, cannot go further in or further out than this or that. And then these bones, I can take them out again with a constraint on the position. You may notice that like as I take those out, they rotate slightly. And that's because as they come out, there is an additional constraint, a look at constraints that starts kicking in. And when they're fully out, the look at constraints is fully taking effect. It's not taking effect at all when it's in. Maybe it's a little more obvious if I open it up wider. Yeah, it's going to be a lot more obvious that way. Look at this. Here we go. So why is this happening? That's because I have another targeting bone right here. And this targeting bone makes the spinners follow it, right? So I have those two spinners are just moving along, rotating along the z-axis, the z-global axis, and then the back panel takes care of moving the pitch, essentially. So the yaw for the spinners and the pitch for the back of the drone. I can disable this constraint if I want to. That's a parameter that I can animate. I'm just going to leave it enabled for now. Maybe I can sort of drag it out, make this into a bit more pretty natural pose for now. The drone, let's say I'm just trying to recover like an attack position from it. So the other thing I would like to do for that is open the top and bottom panel. However, in Blender, there is like a very natural way of implementing symmetry between left and right, usually along the x-axis. You just need to name your bones with like .L and .R at the end. And then with this little button up here, whatever change that you apply on a .L bone will be mirrored by the equivalent .R bone. This does not apply for top bottom, for example, right? Like .T is not mirrored with .B. I wish it was, but it isn't. But you can still like achieve symmetrical motion with a little trick. If I, for example, right now I selected both my top and bottom panels, and as long as I have bounding box center as my pivot point, the transformation I will apply will be with respect to the center between these two bones. And if I scale them up, then I can open these two bones symmetrically. Right, so I can say grab them on the x-axis to do like a nice curve here. But here we go. I've opened up my bone in this attack position, and you can see how easily I can use these bones to create like an opening and a closing animation. While we're talking about animations, one key component of preparing this asset for your game is creating the animations in a way that they can be easily handled in Godot. The first thing to know is that there are two kinds of animations, broadly speaking. There might be more, but I don't know. Like there are really like two broad categories of animations that you're gonna have to make for your model. There's idle type animations or steady state animations. So these animations are meant to loop. Let's say that your drone is just sitting there, open up, staring into the void, right? You don't want to create like a 10 minutes long animation and hope that like your drone is not going to stay in that state for more than 10 minutes. That's kind of ridiculous. You better create like, I don't know, like a 30-second loop or something, or even less than that, depending on how much you want the animation to repeat, right? So as an example of this, I have this idle open animation. It lasts, 120 frames. I don't remember, I have 30 frames per second here. 4 seconds, right? You see the drone is just kind of like loosely pulsating, kind of like relaxed. And then I made sure here that the position of the bone, the position of the drone, the position of the drone's bones at the very end of the animation is the exact same as the one as the first frame. So you can literally grab all of your keys at the beginning of the animation and copy them at the end, and then do whatever in the middle, and you will end up with a looping animation. If you really want to get fancy with it, you can also go in the graph editor. Let's say that I pick one of them here. That's not necessarily a good one. Maybe this one moves a little bit more. Does it? No? Dude, what's moving in this animation? Let's grab them all. Ah, I have a filter on rotation, that's why. Come on. Select them all. Dot. Okay, let's just pick this one. Sorry, this is not going smoothly here. All right, here we go. You see how I have like some of these curves here. These are all the different coordinates. I don't know why they're all underlined in red. I've never seen that before. That's weird. But you can also make sure that like the slope of your curves are matching in the beginning of the end. So like this will avoid creating like discontinuity in the speed at which things are moving, right? Like if the line is flat at the end, but it starts by like going up, it will look weird. It will look like, and then the animation finished and then it stops moving very abruptly. So making sure your slopes on your curves are also the same at the beginning and the end is something you should pay attention to have very nice looping animations. All right, so that's it for looping animations. Let me go back into the dope sheet. And then the other type of animation are transition animations, or animations that are meant to play under certain circumstances. Those animations are usually meant to play as a whole finish. Not always, they can be interrupted. So here's, for example, the close-up animation, right? So this one has a different state at the beginning and at the end. This is important, right? And then I have, let's say, the exact inverse of the animation, the open up animation. And another one that's worth bringing up is that I have this fire animations. When the drone fires its lasers, it charges up at first. Those things spin. And whoops, it doesn't fire, at least not yet. The fire is split in a different animation. Poof, right? And one of the reasons for this is because I want the animation data to dictate when the drone is ready to fire. I want to rely on Godot telling me the charge animation is finished. So now do a bunch of actions, do a bunch of behaviors that happen only when the drone is finally firing. I don't want to have to synchronize this manually and be like, okay, so I look at my animation right now, so on frame 78, which is like 2 point something seconds, then I start, triggering those behaviors. No, I like things to be naturally in sync, and splitting your animations that way is a way to do this, because relying on animations finishing and starting is a lot more clear. So you might wonder like how you end up sort of blending those animations back into like a continuous flow. Well, that's really easy to do with the animation tree. We're going to see that a little bit later. But that's basically it for the animations. This is what I wanted to say about preparing your animations for your game model. One more thing I want to say. So this is going to be relevant for later, but I feel like this is the right time to talk about it because we're already in Blender. Let me go back to the mesh and let's show these weird material-less meshes that I've shown earlier. So these particular mesh that have no materials are for VFX purposes. One thing to say about the materials I have on the drone right now is that I am using multiple materials to color the drone. The only thing I've done to give it this appearance is to go into edit mode and then select a bunch of faces and just like assign a material to it. For example, I can assign this one and whoops, now this is orange. I don't actually want that, so I'm gonna undo that. But this is how I've colored the drone, and this is a temporary measure because every material you assign to your mesh requires an independent draw call from the GPU. So you're kind of wasting resources when you do something like that. You want all of your model surface to be handled in a single draw call, meaning a single material. I could bake what I have right now, but ultimately what I want to do is properly UV unwrap and texture the drone, and I just haven't done that yet. And it's not causing me any performance issue because I only have one drone on the screen. So this is work that I just postponed for later. However, using multiple material on the same mesh is also what allows you to split, to have some mesh still attached to your armature, to your bones, be part of your animations that's on the deformation bones, and still be animated independently with shaders in Godot, right? So if I go back to the armature here in pose mode, you can see that all of these mesh are still attached to the skeleton. So they will follow the drone. And that's exactly what you want, right? So going back here, let's say that I select the exhaust material and I select them. You see that this material is only assigned to this weird mesh that juts out of the engine. Normally, when the drone is not using its engine, these are just invisible. So I have parameters to hide these in-game, right? I just make those VFX meshes invisible. But the exhaust, the engines, and then those three different things here, let me show you what they are. The spinner spikes are these guys. The spinner rays are these things in the front. And the spinner balls are just like this kind of energy buildup that happens inside of the spinners. All of these things are animated independently. And if that's what you want, then it's acceptable to use multiple draw calls on the same mesh, right? So this is what I do here. So another thing is that these meshes, if I go back and select my exhaust meshes, for example, sorry, I need to go back in edit mode here, exhaust meshes, select. They are UV unwrapped in a very specific way. It's very intentional. So if I look, for example, so these are my top meshes. I have two tubular type meshes, like one that's inside, one that's outside. They kind of overlapping because all of this will be like transparent, semi-transparent at the end. So it doesn't, the geometry itself doesn't matter so much as the material assigned to them. But I am putting them on a UV like this such that I'm going to create a square texture where the bottom of it is, let's say, intended to be very bright, and the top of it is intended to fade into nothing. So for example, alpha would be set to 100% at the top, and then there will be some non-alpha pixels, right, that emanates from the bottom and maps onto these things. So I've done UV unwrapping for all of my VFX meshes. They all have different, let's look at, for example, like the spike, right? So this basically means that's another one of those. If I go to the beginning of the spike here, the very top is intended to be very bright and then fade out as it goes towards the tip of the spike. So this is how you can sort of map, you know, UV map your meshes. If you've done UV mapping before, this is nothing weird to you. But my point is that you can UV map certain parts of your model and not others. That's a choice that you can do in Blender. You can select these meshes and UV unwrap them independently. And this is what I've done here. So my model is partially UV unwrapped, just the VFX meshes. Before I leave Blender, one more thing to talk about is how to export this. I was watching recently Blender Studio's effort, like video log on the video game that they've made called Dog Walk, and they talk a lot about their workflow using Blender and going into Godot, and it's super interesting. I really recommend looking into it. However, they worked in a very specific way that I think does not necessarily translate well to solo developers, especially if your experience is mostly in Godot and not as much in Blender. Of course, they are Blender Studio, so their experience in Blender is off the charts. So their preference was to work in Blender as much as possible. My preference is to split the work a little bit more evenly between the two. But there's still this one trick that I've learned for them, which is I recommend heavily. So when you create something in Blender and you want to export it to Godot or import it in Godot, you have a bunch of different options. One option is to export a GLTF file. The traditional way to do this is to go into the export menu over here, export GLTF. Ignore the other 3D file format. GLTF is clearly the best. And then here you have this little menu that allows you to select what you want to export. You can limit to selected objects. There's some always apply Y up in Godot. It really helps. What kind of data you want to include, if you want to include the armature, if you want to include the animations. All right, so all of this is there. The problem is that what if you want to split your Blender scene into multiple exports? Because inside of Godot, what you might want to do is, let's say, okay, I've created all these objects in Godot, in Blender, and then I want each of these to be independent objects inside of Godot. You might want to export this object to one GLP, this object to another GLP, and then import it independently into Godot. The best way to do this is to use collection exports. So inside of Blender, you can split your scenes into multiple collections. And then let's say you have this collection here. There's a little collection tab in this menu, and you can define exporters for it. And you have all of the same options that you have in the export menu that we just looked at, but those settings are sticky. They will persist alongside the collection. So if, for example, you were to select one object, export it, select another object, export it with the file menu, you're going to have to change these settings every time. But since they're sticky to collections, you can just stick your different objects you want to export in different collections, and you will never have to readjust these parameters. You can even like lock in the export path and all of this. I really recommend this. And other options that you have in Godot, just to throw that in, is that you can export the blend file directly. But if I were to export this blend file, I would not be able to separate it easily into different scenes. Like you could do that with an import script in Godot, and I've tried, and it doesn't work as well. Like I highly recommend using just collection exports, individual GLB. Just tailor your GLB to individual scenes that you want in Godot, and you'll be a happy camper. All right, so now that we've done our export, I haven't actually done it, but I've done it not on screen. Let's up over to Godot. So when you import the GLB into Godot, you can grab it from your file system over here and go to Advanced. So let me just reduce the size of this window so I can see it all in the viewport. Here it is. So this is what my GLB file look into the advanced import. You see the mesh, the armature, you see all of the animations, you see all of the materials that I have on it. And the thing that you need, so you don't really need to do anything in the advanced import before importing. There is one thing you really need to do, and it's to basically every animation that is meant to loop, all of my idles, for example, targeting, just need to set the loop mode to linear as opposed to none here, so that those animations, when the animation player is created to contain those animations will be set to looping by default. Because once the animation player is created, it's hard to modify it. Like I found that like there's this weird behavior in Godot where you can modify the animation player, but I would strongly advise against attempting that unless your import from Godot is a one-time thing, which it never is. You're going to want to go back to Blender and fix some things and re-import. And every time you're going to do that, whatever you change inside of the animation player will be overridden. So don't do it, right? So I like to, once I have my GLB, I like to use inherited scenes. It works really well with this model where like your GLBs are already split into objects that you meant to live in separate scenes. And this inherited scenes, you always have the ability to add nodes to it. You can't really take some out. You have to add them, or you can modify the ones that are coming over from the GLB file. Those ones are highlighted in yellow. You recognize the same armature, skeleton, mesh, animation player. And you can see that like in my animations, if I look at my idle, right, this is highlighted in blue, meaning that yes, like the looping setting has been set upon import. So now that I have all of this imported, then how do I control this, right? So this is where the animation tree comes in. The animation tree is one of those concepts in Godot that I think is the most intimidating. One of the reasons for this is because there's 5 different ways of achieving the same result, and it's not clear how to go about applying, the animation tree to your own situation. You're going to find a bunch of YouTube videos on animation tree, and they tend to focus on the classic use case of just a character controller with like walk cycles, run cycles, and then they're going to show that you can use like a blend tree, a blend like 2D space or something like this to sort of smoothly blend between your walk and your run cycle such that like you stick it at a 0.5 value in the middle and it looks like your character is jogging. It's really neat. Blending is generally really neat between animations. You definitely want to take advantage of that in 3D. But there's many ways to go about blending animations. And in my case, what made the most sense is to use the animation tree state machine. So I'm going to try to expand this a little bit to show what my state machine looks like. It looks very messy, right? There's so many edges to this graph. And let me walk you through a little bit how that's set up, right? So if you haven't played with animation tree before, the one thing to know is that the way to control an animation tree in code is to either use like the start command or the travel command. Start will immediately, let's say I say start quick close, it will immediately play the quick close animation or whatever is inside of this node here. If I use travel, it will start from the state that it's currently in and traverse paths, the shortest path that leads me to the quick close animation. So in this case, it will go open up, quick close, right? If I expand this a little bit, and when you click the play button, by the way, it does this travel here. Okay. So I see it went to open up, and then the quick close animation like immediately played, interrupted the open up animation. Let me do it again, right? It tries to open, but then quick close interrupts it, and then it goes right back to the close state. How does it do that? How does it go right back to the close state, right? All of these edges, this is where like you fine tune your animation tree. It's all in the edges. You can, like setting up the nodes is easy. Like every node here is like a different animation that I have. There's some subtlety to setting up the nodes though. Like one of the things that I like to do is that instead of like straight up using the animation itself as a node, I like them to be a little blend tree. So that I have the freedom, let's say that I want to slow down the animation in the future, then I can insert a time scale in the middle so that I can manipulate the speed of the animation here. I'm doing this in my character controller. I'm not doing this with the drone, because with the drone, I'm controlling my animations in Blender. I'm creating them myself. So I don't have the same kind of issues that I have, let's say, with my character, where I'm still using Mixamo animations, which I'm really eager to get rid of at some point. Like, Mixamo is great, but it's restrictive and it's not very personalized. Anyway, so how does controlling these edges look like? One thing you may notice is that there's different colors and there's different symbols on the edges, right? So an edge, so this is just like the color and the symbols is just a reflection of your switch and advance setting. Advanced does not mean advanced setting. It means how you advance from one state to the other. There's ways to, so you can either just have it enabled, and if it's just enabled, it means that this edge can be used by travel. If it's disabled, travel will not be able to take that edge. If it's on auto, it means that once you met a certain condition, you will automatically take that transition, right? So this is when advance is on auto. If I, for example, take this little edge here and I switch this to auto, then the arrow becomes green. And you can see it immediately automatically goes to open up. But that's not what I want. I want the drone to stay closed if it wants to. So I'm just gonna leave that to enabled. And the other thing to know is the switch mode. Do you want the transition to be taken immediately, or do you want the animation to complete before transitioning to the next mode? So this is what a switch mode is about. Immediate will interrupt the animation, and at end will wait until the end of the animation to take the transition, right? So let's say I go to the idle state, and then I go to charge up. Whoa, it played the entire charge up animation before doing the fire animation, right? So when you have the little line here after the play arrow, that means that you wait until the end to transition. And indeed, that's the way I'm configured here, right? So I can be in idle, and I can either ask it to transition to fire, in which case you'll see it traveling through charge up, but it waits until the end to do fire. And then it gets stuck here, despite the fact that I have 2 green arrows. Wait, why is that? I mean, is it because it doesn't know which transition to take? Not really. I don't know what the behavior would be actually if I just like do 2 arrows without this special setup I'm about to show. But the reason why it's not taking either transition is because in my advance, I have an expression condition. So I have these little booleans defined in code that is going to tell the drone, after you're done firing, should you go back to idle or should you go back to targeting? So these edge have these boolean gates. And where are these boolean gates set? If you go back to the animation tree node, you have, if I expand the inspector a little bit, you have this advanced expression base node you can pick. and any variable you declare inside of the script attached to this node can be used as an expression, right? So for example, if I go look at the script for my drone, you see that I have these flags defined here. They have some values to begin with, but I do have these functions here to open path to targeting or open paths to idle, depending on what I want the behavior to be, right? So these are all different ways that you have to manipulate the animation tree, but as you can see, the control of it all it's all in the edges, right? So going back here, one last thing to talk about is the crossfades. So let's say that I'm playing the idle animation. You see that like the drone goes through a variety of states, right? It goes through every frame. The bones have different rotations or different positions. And let's say that I want to close up the drone, right? And trigger it immediately. That means that if I want the animation without crossfades, what I would need is for the first frame of the close-up animation to match whatever is the first frame of whatever is the frame of the idle animations that I'm in. But obviously that's not going to be the case because the drone is not static here. It's true starting from the close position, right? Here the drone is just not moving at all. This is just a single frame, right? And open up always matches that state. But when it's idle and you want to close, that's not the case. So how do you make sure that like every single time you close it, it's very smooth? Well, that's where blending comes in. And in an animation state machine, blending is affected by adding a crossfade time. So here I have 0.5 seconds of crossing, meaning that when I click on idle and then I transition to close-up, the close-up animation starts playing immediately, but the idle animation continues playing for an additional 0.5 second, and there is a mixing between those two animations that takes place that kind of fades one into the other, right? And that ensures that it doesn't matter which state I start from here, like the mixing and makes sure that everything looks super smooth. So this is what you do with an animation tree. Another thing to mention is that like, how do you decide where edges are? And my choice when I'm using the animation tree in code is to use travel all the time. I don't use start. I want to take advantage of blending as much as possible. So every time that I want a transition to occur very fast, to be immediate, I need to add an edge, right? So you can see that's why there's so many edges that go to the quick close animation, because quick close is a defensive move. Whenever you throw the ball at the drone, no matter what state it's in, I want the drone to be able to close itself up and try to defend itself. Except when it's firing, right? There is no edges from charge up and fire to quick close, and that's because that's my vulnerability window. I want you to time your hit just before you potentially get hit yourself, and that's when you can hit the drone. It can't defend itself when it's charging up its guns. And think of it that way. If it charges up and it closes at the same time, all this energy ends up bottled up in the drone, and he's going to hurt himself. He's not going to want to do that. So that's why there's all these edges. And then I have like animations for thrust. So you can see the travel taking place here. So thrust, like the drone is a little bit more closed up. The top and bottom panel are aligned. This is meant to play along with the VFX mesh. So I need to sync my VFX meshes to these animations somewhat, not necessarily, because for example, I can have two different thrust. I can have an intense thrust or I can have a slow thrust. The intense one, I call it burst. And you can see that the position is very different here from the idle. So that's why I have a separate like close animation, a thrust close. So it can also defend itself when it's in thrust mode. So I need to fork my logic in the code, like whether, okay, if you're in thrust right now, then use thrust close instead of quick close and stuff like that. If I go from thrust and I try to travel to quick close, sorry, let me do that again. Idle thrust, I need to wait until it's done. And then I go to quick close. It's actually not too bad. It's still fast, but you can see that it tries to do some other animations in between. So it's not as immediate as, let's say, just picking up thrust close here, right? Bam, that's it. So these are all the things that you need to think about when you set up your animation tree state machine. I'll go over my player animation state machine at some point because it's a lot more complex. There's more stuff to think about there. But that's basically it for the animations that are dependent on the bones, right? Also, maybe one thing I want to show here, if you remember, I was talking about the animations being baked on the deformation bones. If you look at the tracks in the animation player, that's what you see. You see the data like applied to transforms of the deformation bones, right? These are my control bones that are. But anyway, like that's just a little detail I wanted to show right now. Now let's look at the meshes, the VFX meshes. I'm only going to look at the engines for now, but taking a bit of a step back here. Sorry. So yeah, okay. So this particular scene that I've been playing with is, again, just to remind you, an inherited scene from the GLB. And I want this to be a wrapper around my model. It's a wrapper around the model in the sense that it's responsible for everything visual about the drone. It's responsible to control the animations. That's why the animation tree is there. It's also responsible for the VFX. And the top class will give you functions to control all of these animations, right? So I'm not necessarily going to go through this script today. It's not the most interesting thing, or maybe I'll go over it later. But right now, what I want to show is, so let's go back into 3D. Oh, the shader editor is already showing up. Anyway, so now I'm grabbing the mesh. If you remember, this drone had like 10 materials on it. The first 5 are just the colors and the metal. And then the last 4 are my VFX meshes. Mesh number 6 is the exhaust, so I can grab it. I've assigned a shader material to it, and I've created a very simple shader on it. This shader, the way that it works is that I have 2 parameters to control it. I have a noise intensity that either makes it like faint or very bright. And I have a noise speed control that makes the exhaust look like it's moving, right? I can make it faster like that. And that's how the VFX for the engine is constructed. It's just this very simple shader. The only thing that I'm really doing with this shader, so I have 2 textures. Let me hop over to Krita to show you what those textures look like a little bit. This is the main texture. It's not really black. I'm just adding a black background so that we can see those lines here. If I remove the black background, you see that this is just very transparent, so it's hard to see without the black background. And it's tiled along the X direction, just so it can properly wrap around certain meshes. I'm not even sure I'm really taking advantage of that given the UV unwrapping I have on this, but you know, just in principle, it's nice to tile these things that you expect to repeat. And then I have this other mesh, this other texture, which is a noise texture. This one also repeats in all axes, and this one, it's a lot more important than it repeats. So this is what creates the speed effect, the movement effect, along the y-axis specifically. You can see like the noise is kind of roughly stretched along the y direction. So just, again, kind of creating this illusion of motion. And this is just, again, is the same kind of texture as this. It's just like an alpha map. You're just adding the alpha on top of the other mesh, and you're making it drift so that it's looking like there's stuff that's coming out of the engines, right? So hopping back over to the Godot editor, you can see that in my shader code, right? I'm manipulating these 2 textures, texture and albedo and noise alpha, and then I am creating, or I'm using the UV2 built in here to take the first UV and just make it drift along the y-axis using the time built in. Multiply by the noise speed, which is one of my parameters. So the higher this is, the faster it goes. And then in my fragment here, I just retrieved the main texture, assign it the main UV. So like I said, if I remove the noise speed here, this is just a static thing. And then I just color it, right? I can add a color at one end of it and mix it with a color at the end of it. And this is how I can control the color of the exhaust, I can, let's say, like, I don't know, change the color like this. I'm not super decided on what the color should be, so this is why I want the freedom to do that. Maybe I'll take that out if that's an optimization issue, but it really isn't right now. And then I have the noise texture, and I assign it the UV2, which is the one that drifts with the noise speed parameter. And I just combine the alpha from these two textures, and the albedo only uses the color from the first texture. That's it. That's the shader. Very simple shader, 2 parameters to control. And the way that I control this in code now is using a specialized little class that has 3 different states for the engines. I'm using these little data nodes here with export variables to store the different states of the engines that I want, so that I can essentially use this script to set those parameters in the editor. So I have engines off, engines thrust, and engines burst, right? So everything's at 0 for off, a little higher for thrust, and a little higher for burst. So these are just like containers to store the values of my state, and I can easily tweak them because they're exposed in the editor. And this is used inside this engines animation node that I have here. The engines animation node grabs a handle, it injects a dependency for the drone model, which is the top node of this scene. And it uses this node to go and retrieve the mesh. And from the mesh, we retrieve the shader material. And we also retrieve those 3 child nodes here that stores the properties. I have an apply props method that allows me to grab one of these states and just apply the value straight to it in one operation. And then I have these tween engines. This is what allows me to transition between those states. So as you can see, I'm kind of reproducing bits and pieces of what you see in the animation tree, but I'm using tweens on the shaders because I like tweens. They're really simple and neat and light. And while it would be possible in principle to create another animation player and do all this in animation players, I kind of like to use tweens. So that's what I chose to do here. So how this tween engine works is that, first of all, you apply the initial condition, the initial state, and you first check, well, is the initial value for this particular variable exhaust noise speed is the same as the final one? If not, then don't do anything. It's a waste of resources. And if the tween already exists, if it's already ongoing, kill it and then recreate it anew. It will recreate it anew no matter what, even if it hasn't been created yet. I keep references to the tweens in the class so that I can do this. One reason I'm doing this is because let's say that for some reason in the code you are spamming one of those animations and you're not letting it finish before like calling it again. I don't know what Godot does in the backend. I don't know if it wipes existing tweens. I'm not sure. I don't think it does. Maybe it does, but just the idea of having multiple tweens kind of fighting over the same parameter and having this priority handled by some automatic code in there is just, I don't like that idea. So I want to make sure I only have one tween controlling one parameter at any given time. So if I'm spamming the animation, just like kill the one that's currently ongoing and just like start a new one. That's all this does. And then if you've never seen tweens before, they're pretty simple. You grab the object you want to manipulate. You say which parameter of that object needs to be manipulated. You provide the final value and how long it should take. And then there's like ease and transitions, which are, I don't know if this is going to show well on the camera here, but I printed this reference sheet. Gosh, it's hard to see because of the light on the window, but you Google like Godot tween cheat sheet and you'll find this. This is the most convenient thing to have around when you're building tweens. This just dictates exactly what trajectory you take to go from the final state, from the initial state to the final state. So I have one tween for each parameter. I await to see if the tween is done. So that both tweens take the same duration, so it doesn't matter which one I await. But this allows me, so when you use await in a function in Godot, you can also use await on the function, right? You can see this is what I'm doing here. So I'm await inside, and then here I'm using await on the function call. Whoops, I didn't want to do that. But basically await transforms your functions into a coroutine, and you can always await coroutine. So you can just like bubble up the await like this, which is very convenient. And then once I have this tween function, I use it essentially to define the transitions between the states here. And all of these methods end up being called by the main drone class. They're not called by the class directly, but like this is my main drone scene, the one that controls both the animations and the behaviors. And I have a state machines for the engines, and this is the one that controls like the animations of the engines. So depending on what state it's in, depending on what transition it's taking, it's going to call these transition functions with different parameters. As an example, if the drone is currently in thrust mode and I want it to close slowly, let's say that, I don't know, it went back to its patrol loop and it's just very, very chill, it can turn off its engine slowly and then start patrolling on just its normal impulse. And if it needs to defend itself while it's thrusting, then it needs to shut off its engines a lot faster. So then I use a different duration here, right? So that's essentially what this does. One more thing I want to say. I realized that I forgot to talk about this when I was talking about the animation tray. So let me just hop back over into the world of the animation tray a little bit. Animation tray. Come back here. Here you are. It's very, like I hinted a little bit that it's very convenient to be able to wait for animations to finish. And although the animation tree does have animation finish and animation started signals, they're not reliable. There's a number of reasons why they're not reliable, but one of the underlying causes is because of the crossfades. So as I said before, when you do a crossfade, there's actually two animations playing at the same time, and the animation finish signal will kick in the moment another animation starts. So it's not the true end of the fading animation that you get. It might be the true start, but it's not the true end. And also when animations get interrupted, let's say that you have one idle animation gets interrupted, it's a looping animation. This animation never really ends, so animation finish signal does not get triggers. It's basically because those signals are bubbling up from the animation player, and those signals are hardwired to the actual begin and actual end of the animations. So if you want a reflection of, I am in this state, and now I left the states, and now I have entered this other state, you need to do that manually at the moment. And that's why I built this animation state change tracker. All that it does is that it keeps track of which one is the current node in the animation tree and which one is the current fading node. And based on this information, right, I compare the current node with the new current node every frame, current fading node with new current fading node every frame. And based on these comparisons, then I have some logic that tells me whether the animation finished or started, truly finished or started. And I use those signals in the code a lot. Those are extremely useful. As you can see, I still have printout statements left because that logic has a lot of corner cases that I had to discover. So I'm not 100% confident that this is correct 100% of the time. Which is why I may need to resurrect those printout statements, which I can simply do by clicking on this little button if I want to. So those signals are used, like I said, to learn when an animation finished. Let's say I want to learn the animation is, the charge animation is finished. I receive the signal and then I can decide, do I start the fire animation? I need to probe, for example, at this moment, do the drone still sees the player? Does it abort the fire? Or does it proceed with it? Things like that, right? So you want a point in time where you can control this logic. One more thing I'll say before I wrap up here is that, as you can see, I have this node that controls all of the animation. I have this node that controls both the animations and the behavior. One decision that you have to make when you have a relatively complex asset like this with independent moving parts is, do I want to make the animations follow the behavior, or do I want the behaviors to follow the animations? And those are not the only two options. You'll see a lot of like these two options being used, and I think that like those make a lot more sense when you don't have transitions between your nodes, or your animations are not, your asset doesn't have independent moving parts. Right? I think this is what makes my situation complicated. I want the engines to be independent of the guns and have their own state. I want the drone closing and opening to be independent of whether it's targeting a player and tracking a player or not. I want these things to be independent to generate emergent and complex behavior. So basically, I have this master class at the top that controls both behaviors and animations. I keep my animations and my behaviors as separate as possible. And let's say that I tell the drone to open, for example. The drone is closed, I want it to open. I'm gonna do both triggering the animation. This is where I use the travel method, and telling my state machine that controls the state to open. It will trigger some behaviors. When the drone is open, for example, now it needs to be alert that the ball may come to it. It becomes defendable, a little bit vulnerable. When it's closed, it's completely invulnerable, right? That's the kind of behavior that I want to trigger here. So I control both my animations and my behavior here. In the case of the VFX mesh, this one maps directly onto the state of the engine, which is why the VFX mesh is actually controlled by the state machine itself. So you have to apply these judgments, right? Like you have to use your own judgment as to what is controlled, and it's not easy, it's hard. You have to iterate to figure out what is the best model for you. But I just wanted to show that like it gets more complex than I feel people are going to tell you on Reddit. You can ask questions about how to design these things on Reddit, but like people never really have the context that you have. Their advice may be good, but may also not apply, and you need to exercise a lot of judgments on that. Lots of judgment. But yeah, that's it. That's everything I wanted to discuss in this video. So let me close by playing the game again. So now that you've learned how all of this works, you'll see this in a new light. So let me just bring back the game. Here we go. Prototype. In one of my attempts at recording this video, I had a really fun like emergent behavior happen where like the drone was using its engine at the same time it was trying to fire its guns. And that's exactly what I'm after. Like I want what I build to even surprise me, right? But you can see like it used the guns there. How would I trigger that behavior? Can I do that? Ugh, it hits me. I'm gonna let it do the ram attack so you can see the engines, right? This is a burst. Then it's gonna burst back at me, close very quickly. It rolled up the hill. Then, yeah, so that was a thrust. Because when the drone is far away from the patrol position, I want it to thrust back to the patrol position. If I run away, if I run out of its sights, see, now it's thrusting back, but then it sees me again and it opens up. All these behaviors. Super fun stuff. Anyway, that's it. Before I end the video, let me just say a huge thank you to Chapsy. I will link his YouTube channel in the description. He is one of the main reasons that I'm doing this. We've been hanging out together on his Discord channel for the past year. He's building his own game, his own 2.5D video game, and it's amazing. Just go look at his channel. I'll link it. And yeah, if you are interested to talking to me, you can actually reach me on his Discord channel. So that's it. Thank you so much for being here. Next time I'll go into another topic that delves into this kind of complexity. Hopefully this wasn't too long, and all right, and I need to end this. Bye-bye.